Okay, so Unit 11 is about probability. And just as a review, since you probably haven't talked about probability since 8th grade math, maybe 7th grade math, but we're going to kind of start fresh for all students, okay? So experimental probability is the chance or likelihood of an event happening. It is between the numbers 0 and 1, including 0 and 1. If an event has a 0% chance of happening, that means that the event is impossible. And there are impossible events. So the assigned probability would be 0. If an event has a 100% chance of happening, that means the event is certain to happen. There's no other outcome that could occur. The assigned probability is going to be 1. So if an event has a 50% chance of happening, it is going to be a probability of 1/2. You can write that as a fraction or a decimal. All events have an assigned probability between 0 and 1, or 0% and 100%. Okay? So a few definitions, just so you know the words that we're referring to. Outcome is going to be a possible result for one trial of an experiment. So like, let's say I was rolling a dice. An outcome could be I rolled a 4. All right. Oops, I put it in the wrong spot. The sample space is a list of all possible outcomes. So if I was rolling a dice, and we're always talking about fair dice, my sample space would be 1, 2, 3, 4, 5, 6. Those are all the possible outcomes I could get when I roll. Union. This might be new, just depends. It is a set containing all the elements that are at least one of the two sets. So we can use two different ways. We can use the word or this symbol, which stands for a U, that also means or. So it's A union B, or A or B, okay? And so basically, an example would be if I had $5 or a phone. Well, or combines them. So I actually would have both. I could have both of them. And so you have to list both of them as a possibility. All right. Intersection is, we'll do union and intersection more when we do our examples. Intersection is a set that contains all of the elements that are in both sets. So it's kind of where they overlap. Okay. We can use the word and, or we can also use the symbol. This is like an upside down U. It's not a U, but it means intersect. And you say and when you read it, or intersect. Okay. Complement. Complement is a set of all outcomes that are not being asked for. So like if A was the event of picking a pink bag, then A prime, that's the notation for a complement. A prime is the event of not picking a pink bag, and that refers to anything, okay? All right, together, we'll make a little note that the event plus the complement should be our total probability. It should add up to 1, because if something can occur 5 out of 6 ways, it cannot occur 1 out of 6 ways, and so when you add those together, you'll always get 1. All right, let's refresh your memory on what probability is. It is simply counting the number of ways an event can occur, and they'll tell you what event they're looking for, and you divide it by the total number of outcomes possible, okay? It does get more complicated as we learn more information and rules in Unit 11, but that is the basic idea of probability. The notation, you're going to see a capital P with a parenthesis. Sometimes they'll write the words out, sometimes they'll use the notation, so just be flexible. Typically on your quizzes, I should see the original fraction. I'm okay if you leave it that way or if you reduce it, but there are 3 different ways you can write probability, and I'm pretty flexible. You can write it as a fraction, as a decimal. I really only prefer the decimals if it's an exact decimal like 0.25. If it repeats, then the fraction is going to be the best, or as a percent. Okay. I typically don't even bother writing a percent because you just have to use a calculator. This is my preferred, is to write it as a fraction. It also helps me see which value you are doing incorrectly if there's an error, and so I can address that. All right, we're going to start out pretty nice. So example number 1, we have the spinner here. And it says, what is the sample space? So you really do want to list all the outcomes. And sometimes if this is 20, you do need to list 20 of them out, okay? So don't just summarize like, it's all the numbers. Write them out. That's the whole question. So the sample space would be 1, 2, 3, 4. Now, part B. What is the probability of spinning a 2 in one spin? And so this is what it would look like in notation. Well, you got to think, how many ways can I get a 2? That's one way. Out of how many total possibilities are there? 4. Okay. What is the sample space for the sum of 3 spins of the spinner shown? So you kind of want to organize this information. So I'm going to put a little list here, and I'm going to do, this is like my work. Well, you have to think, what is the smallest sum that we could get? Well, the smallest would be if I did a 1 on my first spin, a 1 on my second spin, and a 1 on my third spin. So I would get 3. So that's going to be my first sample space. And then I like to think of my largest. So I think, well, what if I did 4 plus 4 on my second spin and 4 on my third spin? So I would get 12. Now, is it possible to get all the numbers in between? And that's what we'll kind of play around with. So let's see. Can we get a 4? Well, I can do a 1, and a 2. That's a 1. Now, I also could get a 2 first, then a 1, then a 1. But notice my sum is the same. Okay, so they just want all the possible outcomes. They don't want to know how many different ways. A sum of 4 and a sum of 4, no matter how you get it, is still the same sum. Does that make sense? Well, could we get a sum of 5? Sure. What if I did a 3, a 1, a 1? Okay, and there might be other ways to get it too. So yeah. So I can get a 5. Can we get a 6? Sure. What about a 3, a 2, and then a 1? A 7, see where I'm going with this? And so I kind of like to organize it. Now, notice I'm not going to find any probabilities because this would take a lot more work, but you can list a sample space. And so as we go, because we have all of these possibilities, we really are going to be able to come up with all of the values in between. That won't always be possible. It just really depends on the spinner that you're using. Okay? All right. Example number 2. We are going to make a Venn diagram. So this might be a blast from middle school. Who knows? Within a track team, there are 15 members who run sprints. So it looks like we have sprints. 10 members who are long jumpers, and 6 members who run both. And so we need a Venn diagram. So it's going to have 2 circles because we have 2 events. And since we do both, we want them to overlap. Okay, and so I'm going to just make this sprints and long jump. And we want to fill out this information because then we are going to complete some of the probabilities. So the first thing I try to address is where they overlap. So that's the intersection. And so in here, wherever they both interlap, because it's in the long jump circle and it's in the sprint circle, we've got our 6 members. So I'm going to put a 6 there. And so that's what that would mean if you would be given a Venn diagram, because that happens too. Now, next, I want to ignore this part of the long jump circle. Let's talk about sprints. It says we've got 15 people who run sprints. Now, we already have 6 that are in the sprint circle. So that 6 is counted as part of the 15. So what we want to figure out is how many are going to only run sprints. And they didn't give you that information, but you have the values to figure it out. So if I know there's 15 total and I know that 6 are already sprinting, I can take that off of my sprinters and we would end up with 9. So there's going to be 9 people who only sprint. Okay. Now we're going to ignore this sprinting portion and I'm going to look at the entire long jump circle. Same thing, I have 6 people who are already long jumping, and that's part of that 10. So take off 6, and I'm left with 4 people who only long jump. Now, sometimes if there's a number outside here, it means that they don't sprint and they don't long jump at all. Okay, and so you might see numbers on the outside. We don't have any more information to use, so we don't have any people who, that we know of, don't do either of those events. All right, so let's look at this. If one student is selected, what is the probability that they will be in both? Well, we got to figure out how many are in both out of how many people are there total. So we know that there are 6 people who do both. Now, the total, if we go up to the problem in words, we might just want to start adding all the numbers up. But go to your picture. That's kind of the advantage. I've got 9 only sprinters, 6 that do both, and 4 that do long jump only. So 9 plus 6 plus 4. 9 plus 6 plus 4. I'll show my work. So I get 19. So we get 6 out of 19. All right, and that's it. How many only sprint? So now that we have our Venn diagram, I've got 9 that only sprint, and we still have that same total. The long jump, it didn't say long jump only, so we need to actually look at the entire long jump circle. Okay, see the difference? So I've got 10 out of 19. All right, example 3. You are given a Venn diagram, and we're going to use kind of the focuses on the words or and. All right, and so we don't care what these events are. We're just saying event A, there's 12 people, event B, there's 30 people, and then we've got this 8 that aren't in either. Okay, and notice we don't have any of overlap. Now, this is a word we're going to definitely dive into more in section 11.2. Mutually exclusive means that they don't have any outcomes in common. So we are going to say yes. Okay, like I said, I won't test you much on 11.1, but when we have Venn diagrams, this is where we're going in the next section. So I'd like to give you a little preview. Our second question says, find the probability of choosing a person from event B. So I need to figure out how many people are in event B out of how many total. So I've got 12 plus 30 plus there are 8 people that are still possible. They're in our sample. So what do we get? That's 20, 30, so that's 50. So I get 30 out of 50. Now, I'm actually okay if you leave it as 30 out of 50, but both of those numbers reduce by 10, and so 3/5 is probably going to be the multiple choice answer. You know what I mean? I actually like the unreduced fractions because I can tell where your error is. The probability of choosing a person from event A or event B. So let's talk about or. So or means that we can pick either of them and include them. Okay, that's the union. So we don't care if they're in A and we don't care if they're in B. They both count. So or typically means to add them together. So I've got 12. And I say typically because there are some exceptions. So I've got 12 people from A and I've got 30 people from B. Since there is no overlap, that's why I can just add them. Out of my total, it's still that 50. So we're going to get 42 out of 50, which I'm good with, or we can divide by 2, and I get 21 out of 25. All right, and. So the difference with and is it has to be the intersection. So these people have to be at both events in order to count. Okay, see the difference? So if I go down here, well, there's nobody that's in both events. So it really is going to be 0 out of 50, which is 0. That is an impossible event. Okay. I could have said neither A or B, and then that would be the 8, but I didn't. All right, let's look at example 4. So we have event C and D. We do have some overlapping, some people that are in none, some people only C, some people only D. So the probability of choosing a person from event C. So I really am looking at that entire C circle. It does not matter if they're in both. They get to count if they're in the C circle at all. So I get 20 altogether out of, let's figure out what's our total. we get 14 plus 6 plus 2 plus 13. So 20 plus 15, 35. Well, I'm okay with that, or divide by 5 and we get 4 out of 7. The probability of choosing a person from event C or D. Now remember, or means they can be in the C bubble, they can be in the D bubble, and they get to count. But what happens is I can't count that 6 twice. So I can count the C only, both of them, because that definitely counts, and the D only for or. So I've got 14 plus 6 plus 2, which is 22 out of 35. There's still 35 people altogether. Well, that doesn't reduce. So that's why it's, choosing a person from event C and event D. So remember, and means you're only picking one person, so they have to actually be in both at the same time. And so we want that overlap. So we get 6 out of 35. The probability of choosing a person not from event C or event D. So, well, let's think about that. How many people were in event C or D? Well, we did that up here. So if I have 22 that are in C or D, the not means I can't count them, I can't count them, and I can't count them because it was or. So I can only count the other people, which is 13. Now, this is the complement since it's not. I could do it that way logically, or since I already knew there were 22 in both, I could have taken that off of my total and I still get that 13. Okay, lots of strategies. So a little review of Venn diagrams, the words and or, probability, outcomes. Go ahead and give 11.1 a try. Good luck.